In this video, I'll walk you through the Watertight geometry guided workflow, which is new for release 19.2 of Fluent in meshing mode. The name Watertight refers to CAD models that don't require much cleanup. For example, when all surfaces are present and properly connected, and shared topology is enabled for multiple components. Note that the workflow can be completed entirely within the Workflow tab in the Graphics window, although you can still access all of Fluent's meshing capabilities that are outside of the workflow if needed. To start, I'll select Watertight Geometry from the drop-down list. This will result in a pre-populated series of tasks that I'll need to complete in order to generate a volume mesh. The first task is to import a geometry file. For this demonstration, I'll be creating a volume mesh for an external flow simulation around a remotely operated underwater vehicle, or ROV, which is commonly used in deep water industries such as oil and gas. I'll start by choosing the correct units. Advanced options provide additional controls, but the default values are sufficient in this case. Next, I'll simply browse to the model that I want to import. In this case, I'll select an ANSYS spaceclaim file. You can see that after completing the task, its icon has changed to indicate its status. Completed tasks display a green checkmark. Incomplete tasks are indicated by a lightning bolt icon, and exclamation points appear when a task contains a problem that must be resolved before continuing. Note that for the purposes of this demonstration, I've kept the ROV's enclosure relatively small. To ensure accurate results in a real simulation, I would want my enclosure to be much larger. For more control of the mesh distribution, I can choose to add local sizing to previously named faces or bodies of influence. I'll create a local sizing for the surface of my ROV. I'll give the size control a name, and I can adjust the target size based on the preview, which is displayed in the graphics window. In this case, I'll leave the defaults and click Add Local Sizing to move on to the next step. Before creating the volume mesh, Fluent creates a conformal surface mesh on all geometry objects and identifies regions that need to be filled later. An extensive list of options is available for advanced users, and the predetermined settings are sufficient for most cases. As you can see, a minimum and maximum cell size is calculated based on the imported geometry. These can be previewed by clicking the input field. You can see the cell size represented here by these red cubes, and I can clear the display by clicking Clear Preview. I'll make a few small modifications and click Create Surface Mesh. This warning in the console tells me that the initial surface mesh doesn't meet the default target skewness limit. I can also see that the green check mark next to the previous task includes an asterisk, which indicates that although Fluent will allow me to continue, this task may contain a setting that requires additional attention to get the best results. You can review any warnings or messages by right-clicking the task and selecting Show Errors and Warnings. To resolve this issue, I'll insert an Improve Surface Mesh task. Note that changing the face quality limit too extensively may result in aggressive changes to your mesh, so you should always check that your geometry still appears as intended after this step. I'll keep the default values and select Improve Surface Mesh. That's better. Note that since I've added a new task, I can save this customized workflow for future use, which I can do by clicking here. This provides a robust way to define settings that can be used repeatedly on multiple variants of a design, saving lots of manual intervention each time. I need to describe the imported geometry so that Fluent can determine the correct tasks for the remainder of the meshing workflow. This CAD model has both fluid and solid regions, and I don't need to extract any fluid volume regions. So I'll choose the appropriate options and click Describe Geometry. Here I can review the boundary conditions and change the name or boundary type as needed. Fluent automatically assigns boundary types to appropriately named selections, containing keywords such as inlet, outlet, or symmetry. I'll click Update Boundaries to save my changes. Next, I need to specify the number of fluid regions needed for the simulation. Note that it says estimated number of fluid regions. If there are any additional regions that are connected to capping surfaces, Fluent will detect them automatically. In this case, I have only one fluid region, so I'll leave the default value and click Create Regions. In the Update Regions task, I can review and edit the cell regions that Fluent created in the previous step. I'll change the name of the fluid region to Water and select Update Regions. Note that any dead regions are treated as voids and will not be passed onto the Fluent solver. Lastly, under Create Volume Mesh, I'll increase the number of boundary layers and uncheck the Mesh Solid Regions option, since I'm only interested in the fluid region for the simulation. I'll then choose to fill the volume with a hybrid mix of hexahedra and polyhedral cells using ANSYS Mosaic meshing technology. If you'd like to learn more about this, feel free to visit the white paper on ANSYS.com. To generate my mesh, I'll click Create Volume Mesh. At this point, the mesh has been generated. The default quality metric, which is the minimum orthographic skewness, is reported in the console. As you can see, Fluent has created a quality hex-poly volume mesh using mostly default settings and a simple, easy-to-understand workflow. Now, I can either export a mesh file for later use or click Switch to Solution to seamlessly load the mesh into the Fluent solver mode. This concludes this demonstration of the new meshing workflow capabilities available for ANSYS Fluent in Release 19.2.